Good morning, everyone, and thank you for being here. And I apologize in advance for my broken English, so if the closed captioning couldn't keep up, sorry about that. Okay. Okay, linked data. I know many of you have heard about linked data, but for those of you who are not as familiar, I'm just going to briefly talk about linked data. So the inventor of the web, Tim Berners-Lee, always envisioned the World Wide Web as a medium or a platform that not only human, but the digital agents, our browser, our machines, everything that is on the web can communicate and seamlessly with each other and can understand the data that is on the web. So that's called semantic web, intelligent web, or other things. But to do that, to get to there, to pave that way, he introduced the idea of linked data, which means that he suggested that, okay, let's use URI for every piece of data that you want to put there so that it can be uniquely identified, it can be retrieved. Of course, let's keep using HTTP because it's working and we do not want to reinvent the wheel. And also, we have developed, the World Wide Web Consortium have developed some standards, and among other organizations has developed some standards like RDF or WL, and let's use those vocabularies for describing our data. And the key here is that we have to link to other data sets, and they would link to us. So if we do that properly, we would get something like this. So this is the linked data cloud as of a couple of weeks ago, and it's keep growing. Okay. So libraries. Maybe arguably a little bit late, but we are pushing to get to the linked data world. And let's say for our cataloging data, MARC data, which is somehow becoming a little bit legacy data in some institution. So we are trying to convert it to linked data friendly format, and of course, get those links from other institutions and they link to us, using some of the standards that I mentioned, like OWL and stuff. But the problem here was that OWL, RDF, or schema.go, or other standards were not somehow up to the task, because bibliographic data is very extensive and very rich in description. So some of these formats were unable to keep up with our needs. So what happened is that Library of Congress, of course, stepped up and developed the BitFrame framework, BitFrame, or bibliographic framework, I guess. Excuse me. And on the right side, you can see the initial model of the BitFrame, which Ian talked about yesterday, and the newer model has more abstraction levels, which I'm not going to go into. So with this, which is based on RDF and XML, so it's a linked data friendly format, and it's developed especially for bibliographic data. So now at UAL, there are a couple of projects that we are working on. So from Abigail, Ian, and Michaela's presentation yesterday, you get some details from Share with EE and LD4P. Sorry for the wrong image. But anyways, so I'm not going to talk about those. You also heard about CanLink, which is a Canadian Linked Data Initiative project, which we are currently working on, and we want to get more theses through the OIA provider from other institutions. And well, you will probably hear from that in like early future. And also our ERA, our institutional repository, which is running on Fedora 4 with all its pros and cons. It's a linked data platform, so using triples. So we said maybe in our last migration, we tried as a pilot to add some URIs to some of our predicates, like item type, like language, and some other things, which is still, that was a pilot, we want to do more, and some other things. So now, this tool, about 2.5 years ago, my supervisor, Sharon Farnell, when we were getting these deliverables from Share with EE, suggested that maybe we can just experiment with our own data, with our own tools, and whatever we have in-house, and try to transform our MARC data to BitFrame data and in the process, maybe enrich the data a little bit. So at the time, these was the tools at my disposal. So I knew XSLT, and we have a license to Oxygen, to Saxon. And I knew Python, I knew Bash or shell scripting, and of course, OpenRefine was also available. So with these tools, I developed this process. So it started by the MARC file, obviously, and use a Python library, very famous Python library, PyMarc, to just get the MARC XML. And then I fed that to the MARC to BitFrame 2 XSLT package out of the box from Library of Congress, so no changes there, and get the BitFrame. And this is just for our own processing ease. So because it's XML format, you can easily merge those BitFrame files. So instead of like processing 10,000 files, you can process one file of BitFrame which has 10,000 records. So I just wrote a script to do that. And then, again, with another XSLT or a style sheet, I extracted all the names and the subjects, because that was our initial goal as a pilot, and put it into a TSV file, and then fed that TSV to OpenRefine, and do some data cleanup, and using the OpenRefine reconciliation services, enrich the names with URIs, get it to another TSV, and again, using an XSLT, write them back to the BitFrame file, and then we have the enriched BitFrame file. Okay, so this is an example of that. So let's say this is the BitFrame file here, which is generated by the Library of Congress MARC to BitFrame converter. And you can see there is an example.org URI, which is just a placeholder. I use that as an ingest key because that's unique within the file. So I use that as an ingest key. So the TSV that I got had the name, the ingest key, which is the example.org, and those two things. So this is the TSV that I fed into the OpenRefine. And this is the TSV, or the row of the TSV that I got from the OpenRefine. So it has the name, the example.org as the key, and the YF and LC numbers. So that the other XSLT that I talk about would go into the BitFrame, look for that example.org key, and whenever it finds it, it will just replace it with the LC, and if there was a YF as well, it will just put the YF there. Okay, here's the breakdown of the process. As you can see, there are many tools, and the times are not low. So, and because all of these things, there are a lot of tools that we have to use. So I have to use get the results from PyMarc, put it into Oxygen, then put it into OpenRefine. So it was a little bit error prone. So, and I thought to myself that everything like XSLT, data cleanup, API calls, everything I can do using Python. So for the next phase, I said, okay, I'm going to do it from the scratch. Now I'm going to develop everything in Python. And while I'm doing that, maybe I can just use a graphical user interface for people who are not comfortable using command line. So I adapted Django framework and developed everything there. So some of the functionalities that I added is the fact that you can now select the number of APIs that you want to make calls. So if you want to just use LC, just use LC. You don't have to make calls to YF and get more time, get more processing time. It will generate some statistical data, which might be useful for some people. And it can go work with BitFrame or MARC file. And of course, you can still merge the BitFrame file just to make your processing easier. And it can do multiple processing. So you can process multiple files at the same time. Of course, it's restricted by the number of threads that your CPU has if you don't want to crash it. So just a little bit disclaimer here that this project was not developed to compete with SafeShareVD or the Sinopia, but it was just a pilot, and it could be useful for people or smaller institutions who just can't afford to join the cohort, and maybe use this tool to experiment with their mark and convert it to BitFrame and see what happens in the process. And everything is available in GitHub for free. We do have a licensing issue, but we'll fix that, I promise. OK. And these are some of the APIs that we are using right now. So 2 APIs from Library of Congress and 3 APIs from YF. And also, while I was doing that, we added another experiment to our project, and we tried to get the work IDs from OCLC. And this is the diagram chart for that. As you can see, I got the titles and authors from the BitFrame file. Then I fed the titles to an OCLC or WordCat API. I got the results. Then I matched the title author pair to whatever I got from OCLC. And then once I find the correct word, I do another API call, get the work ID, and put it back into the BitFrame or BF work RDF about. So I get the URI there. And this is a sample of that statistical data that I said that it can provide. So it's nothing very specific. It just says this file was done in this amount of time. This many names was extracted, unique names, so you don't have to run duplicate API calls. Corporate names and personal name, because I have like YF corporate and YF personal API, so you don't want to like mix those things. And some statistical data and just a simple graph. And this is the interface itself, so very simple, nothing special there. So just press start, then you will have the option of like uploading your MARC or BitFrame files in there. It would go to an SQLite database, and it would be shown here with minimal metadata. Of course, you can delete them. And here's where you can actually select the APIs that you want to make a call to. And I put some JavaScript restriction on the red process button that it wouldn't go over 4. It doesn't let you to go over 4 because I don't want to crash the system. And also there is a restriction in the backend code that doesn't allow you to do that. But you can obviously increase that if you have a more threaded CPU. Anyways, and of course you can also you can also merge the BitFrame files, so you can go like 3 MARC files and 20 BitFrame files. You will still get 4 process. And once you press process, for this example, I'm processing 2 files, and as you can see, it will just show the details of your process and everything, and how things are working, and what stage it is at. And once that's done, everything will go to the process archives, and you can see the details of like the number of names, the title, and everything was extracted, and some of the results in API calls. Okay, coming up, or what's next? I do want to add, like, because I said we might, like, some institution might want to use this in their internal network. So I just wanted to use or add some user registration and authentication. And of course, they would have their own profile, so they can use their own like private or public files. And more importantly, I just want to have a download button there, because this is something that is lacking. Because here, everything, once the process is done, everything would go and be saved in a folder in the server or wherever the Django application is running. But it would be good to have the download button. Maybe I do that first. Anyways, and well, thank you for your time.
Any questions? I'll start off then. Have you encountered any API rate limits that slow down your software, or have you been, it seems like that would be the only bit that's...
Yeah, well, nothing with YF or LC, but OCLC, actually, you need a permission key, so a WS key or something like that. So we did actually, like Ian was kind enough to get that for me, but if you don't have that, you can do the title enrichment. But other than that, not much.
Any further questions? All right, if not, please help me thank Danoosh for his presentation.